Good evening, and welcome to Real World Chemistry News. Today's topic of discussion pertains to petrochemistry, the study of chemicals derived from petroleum and natural gas. Whether it is found in consumer products such as the phosphate-rich fertilizer used to fuel lawns and threaten to cause eutrophication of nearby bodies of water, commercial use such as the phenoxyethanol utilized for mega products, or industrial products such as the methanol for thermal insulation and building construction. Various forms of these petrochemicals are pivotal for everyday civilized life. So how are these petrochemicals produced? Let's ask our scientific researcher, Dr. Johanna Dunberg.
Johanna Johannesburg. Welcome. And I'm here right outside the cracking pit facility in which raw petroleum is converted into useful petrochemicals.
When converting the raw petroleum and natural gas into useful hydrocarbons, the petrochemical power plants release fossil fuels of carbon dioxide and water, the byproducts of combustion, yet not a significant amount to cause climate change. For instance, the plastic manufacturing is capturing carbon in an inert form, the plastic, yet not releasing it into the atmosphere.
The world, as a small number of people have been saying lately, will not end in 11 years.
Well, good. At least one of the associates of the World Economic Forum is on our side.
Build back better, blah blah blah.
Anyhow,
In this process, hydrocarbons such as propane, ethane, or butane are separated from crude oil or natural gas liquids by distillation, which can be transported into a manufacturing facility known as a cracker. Some examples of petroleum petrochemicals include toluene for creating links and sports equipment, ethylene for consumer electronics and paper, and alkenes for packaging materials and ropes.
refineries such as this one are required to remain economically, electrochemically viable in the market, and therefore they need to be constantly changed into increasingly more complex processes. But they got another process. Gott in Himmel, es war eine lange Woche.
Well, what is the new method?
It uses less hot furnaces within liquid catalytic cracking, which means I cannot afford that thorium oxide catalytic bed, which will not be consumed by the chemical reaction.
Dr. Dunberg, for those of us who don't understand, can you please explain what that means?
Alright, this process pertains to piping crude oil into hot furnaces.
The resulting liquids and vapors are discharged into vacuum distillation units, where they are separated into components or fractions based on their boiling points. Heavy fractions such as gas oils with the highest boiling point sink. Medium fractions such as the kerosene remain in the middle, and the light fractions such as the gasoline float and condense. After distillation converts most of the liquids into intermediate components of steam, heavy, lower value fractions can be processed into light, higher value fractions. Cracking uses heat, pressure, catalysts, and hydrogen to break these heavy hydrocarbons into lighter ones. To produce gasoline, refinery technicians combine streams and determine the blend by octane level and vapor pressure. The final product is stored in large tanks near the refinery, available to be carried by pipelines, trains, and trucks for distribution locations. Thank you, Dr. Dunberg. And as a bonus feature, here is the nation's most beloved scientific non-scientist, Jill Earl, the science girl, here to demonstrate how oil boom sorbents can absorb oil in the ocean.
Science rules. Welcome back to my channel, Maxwell Boltzmann and Summertime Party Girls. In today's video, we are going to conduct an experiment on the effect of oil on water using various types of absorbents. Let me show you. The inspiration for today's experiment was based on those oil booms which encirculate the parameters of oil spills to absorb the surface of the oil. Let's get to it. For this experiment, you'll need a glass clear container, one of the absorbents including laundry lint, face mask, a makeup remover pad, but cotton balls will work equally well. It's a paper towel. Then you'll need a pipette or any kind of makeshift dropper which drops the liquid, sunflower oil, or any kind of related cooking oil which may emulate the oil spill. And our last material is 500 milliliters of distilled water. Now, first of all, we need some laboratory safety techniques. For instance, this is not exactly adequate for a laboratory safety equipment environment. All right, I'm ready. And just in case, let's put on an extra pair of goggles because we're dealing with real-world versions of petroleum in an abstract setting. Not very effective, it's just swirling around. Not very efficient, but at least it soaked up some of the oil. Not very efficient. The last may actually become more promising, since it is made of polyester fabric, which is about the same consistency as the oil booms. Alright, so now we determined that most of the absorbents are not very effective in clearing the oil in this water. Then we have understood just slightly more how difficult it is to clear the oil in both the Gulf of Mexico Deepwater Horizon oil spill in 2010 and the Exxon Valdez in Alaska in the 1970s. Let me tell y'all to stay curious. Back to you, news anchor.
Stay curious and good night.